Hello, everyone. So we're going to go through review 3 here. Not just the answers, but the explanations as well. So I'll pull up some PowerPoint because as you probably noticed, I focused on the things that we said we wanted to review or looking back at the test, what we had trouble with. So percentiles was one of the things that we wanted to go over. And then all the probability distributions, I think some of us had a bit of trouble deciding which one to use and the properties of each. So we'll go through a bunch of examples with those. And then I also put some of the central limit theorem, normal distribution questions in there as well. So let's start with number 1. As you see here, I numbered each just to make it easier. You obviously don't have to do that on your paper, but first thing it asks us is the score of 88 corresponds to what percentile? So if we remember our formula here, to find the percentile, I count the number of values below the value. So that should be in order. So notice that this one's already in order. So the numbers are already in order for us. Otherwise, we may have to do that. But I count the number of values before it, add on 0.5, and divide by the total number. So going back to this one, 88 is here. So I can, as you can see, there are 13 values below it, right? So take 13, add on 0.5, and then I divide by the 20 values total. And then we multiply by 100. Okay, so if I type that in the calculator, basically 13.5 over 20. So 13.5, 20, that would give me, and if I multiply by 100, just move the decimal, which is 67.5. So I would run the estimate about, say, the 67th percentile. I want to write the 67.5. So we don't really use 0.5 percentile, so we'll say about the 68th. Okay, so what score corresponds to the 35th percentile? So remember, if I want to go in the reverse direction, we have this formula here, but we have to remember the specific parts of it, right? So basically, it's the total number of values times the percentile over 100. So it's a pretty simple formula. So let's do that, and then we'll follow our rules here. So I do the total number of values is 20. So 20 times P, we want the 35th percentile. Okay, so I want to do that. So let me type that in. So we want to do 20 times the 35 and then divide that by 100. So you can do it in your head. So divide that by 107. Okay, so this will give us 7. But if you remember, going back to our rules, if I don't get a decimal, if I get a whole number, we have to use the value halfway between the C we got and C plus 1. Okay, so since we got a whole number, we have to go, since we got 7, I have to go halfway between 7 and 8. So the 7th and the 8th value. So going back here, the 7th value is 78 and the 8th value is 79. So my answer here is going to be halfway in between that would be 78.5. Okay, so halfway between the 7th and the 8th value. Okay, and if we got a decimal, we just round up. So if it was like 7.1, I would just choose to round up to the 8th value. So getting a decimal is actually easier. Okay, so I do the same thing for the bottom one here. 20 values, I want the 85th percentile. So 20 times 85, so if I do that on my calculator, that would give me 1700. So if I divide by 100, just get rid of 0, so 17. Okay, so once again, it's a whole number. So we have to go halfway between the 17th and the 18th value. So since it's labeled, so these two here, so that'll give me a 92.5. All right, let's look at number 2 here. So now we have 25 values. So same formula, but we're just going to use 25 instead of 20. Okay, so the value 13 corresponds to what percentile? So 13 is here. Okay, so that's the 9th value. So that means we have 8 values below it. Okay, so remember the number of values below it, add on 0.5 and divide by the 25, since we have 25 total values now. Okay, so I'll do the 8.5 over 25. Okay, so that'll give me about 34. That'll give me the 34th percentile. Let me use the 34th. Okay, so if I look at 33, so that's here, which means there are 18 values below it. So I want to do the 18.5. So add on 0.5 and then divide by the total number of values. So that'll give me the 74th percentile. So 18, add on a 0.5 and divide by 25. That'll give me the 74th percentile. Okay, and the last one, we have to use our n times p over 100. Okay, so we have 25 values here, so that's my n. And we want what value corresponds to the 60th percentile. So there's my p here. Okay, so I'll do 25 times 60. And then divide that by 100, so 15. Okay, so I purposely made these whole numbers just to review because that's the rule. So if I do get a whole number, I have to go halfway between the 15th and the 16th value. Okay, so let me clean this up here. So 15 and 16 will be here. Okay, so halfway between 24 and 28. So if I average those out, 26, right? So the value of 26 would be the 60th percentile. Okay, and it should make sense because if I have 25 values, if I go halfway, 12 and a half, I split that in half, like that's 50% of the data. So 60, it should be a little past 50. So that value makes sense for us. If you think about, if you want to do like median and quartiles, like split it up, the midpoint of this side, the midpoint of that side, split up into quartiles, sort of break it up, that value. So our answer should make sense. Okay, moving on to the probability distributions. We have 5 red cards, 3 green cards, and 1 blue card. Okay, so one thing to note, it is, we do have replacement here. So every time we select a card, it is replaced. That is important. Okay, selecting 5 cards at random, and what is the probability that we want? So we want 2 red, 1 green, and then 2 blue. Okay, so notice we have 3 possibilities here. So I can't use binomial because bi is for 2 possibilities. So we're going to use multinomial here. So remember, multinomial is pretty much the same thing as binomial, just with more than 2. And we do need replacement. So if I pull those slides up, so our formula looks like this, right? So it's basically like the binomial, just add on 1 more possibility. So it's how many of each we need, and then the ways we can arrange it. Right, because if I have 4 games, well, that's 4 factorial. But remember, we have to divide by any that repeat, right? Because, for example, I have 2 W's here. So if I switch these 2 W's around, it's still WWTL. That's not a new arrangement. So dividing gets rid of those, just switching around, and it's the same thing. So those repeated ones. So our formula looks like this. It's the number of values, then we split up into how many of each we want. Okay, so here, get rid of this as well. Okay, so we're selecting 5 cards at random. So the ways we can arrange that would be 5 factorial. Remember, we want 2 red, 1 green, and then 2 blue. So we split up into how many each we want. Remember, that's just taking, because if I have red, red, and if I switch those around, it's still the same thing, right? So I don't count that. So doing dividing gets rid of that separate, counting that as a separate arrangement. Okay, so then we ask ourselves, what's the probability I get a right card? So there are 5 red cards, and we have 5, 3, and 1. So we have 9 cards total, right? So it's a 5 out of 9 chance of a red card. For green, we have 3 green cards out of the 9. And then for the blue, we have 1 blue card, right? So 1 blue card out of the 9. Okay, and obviously, if we talk about replacement here, replacement's important. 1, because if I didn't replace it, it would be impossible to get 2 blue when there's only 1 in the deck, right? Or 1 in the box. So that would just be impossible if we weren't replacing it. But since we are replacing it, we can use our exponents here, right? Because we want 2 red, so we want 2 of these. We want 1 green, so just 1 of these. And we want 2 blue, so we want 2 of these, right? Because remember, what exponent is just repeating, right? So if I square, this is 5 over 9 times 5 over 9. So by squaring this, we're not changing the probability, right? So we're not taking away 1 each time. So for multinomial, replacement is important. Otherwise, we won't be able to use exponents. We'll have to take away 1 each time. Okay, so I type this in my calculator. So I go to my calculator, go to my fraction button here. So on 5, remember factorial, go to math. I go over to probability, and then it's the 4th one here. Okay, so 5 factorial. Then we want to divide by 2 factorial. Remember, 2 factorial is just 2 times 1, which is just 2. So I don't really need to put the factorial there. 1 factorial is just 1, and then 2 times 1 again is just 2. But if you want to make it look exactly like I wrote it, you're more than welcome to, but not necessary. Okay, so we have 5 out of 9. We want 2 of those. Then we have 3 out of 9. If you want to simplify that, you can. We just want 1 of those. You don't really need to put the 1. And then 1 out of 9. And we want 2 of those. Okay, so type in the exactly as you see it here. And I set round to 4 decimal places, so this will give me 0.0381. Obviously, that 0 isn't big enough to bring up the 1, so that would be my answer. So about 3.8% chance of that occurring. Number 4, a store owner estimates it's a 13% chance for a spam phone call, so 0.13. Okay, so if he receives 20 phone calls, we want the probability that exactly 5 are spam. Okay, so we have 2 possibilities, right? It's either a spam phone call or it's not a spam phone call, it's a regular phone call. So we can use binomial here, right? Because if I have 20 phone calls, I'm not going to do all 20. So let's say these are 20 dots. If I want the probability that 5 are exactly spam, well, it could be, I don't know, 1, 2, 3, 4, 5. It could be these 5, or it could be these 5. We need all the arrangements, right? But regardless of how these are arranged, remember, it's going to be 0.13 times 0.13 5 times, right? So we want 5 of those, so I can simplify that to 13 to the 5th. And remember, if I have 5 phone calls that are spam out of the 20, that means 15 are not spam, right? So that means these 15 are not spam. Okay, so that means if it's a 13% chance it is spam, that means it would be an 87% chance of not spam. And we want 15 of those. Okay, so now I just need the arrangements, right? So my arrangements, we have 20 phone calls. 20 phone calls, and I want to arrange how those 5. So 20C5. Okay, so this is my binomial formula. So basically, in all my arrangements, we're going to have 13 of those be multiplied and 15 of those be multiplied, and then just the ways all those could be arranged. So you could either type that in as you see it, or if I go to distribution, let me clear everything. So second distribution here, go over to binomial PDF. So probability distribution function, PDF. So we have 20 trials here. Probability is 13%. And we want 5 successes or 5 spam phone calls. Okay, so this will give me 0.071. And then the 7 brings the 2 up. So 3 if I pick 4. So that'll be that one. And you get the same answer if you type it in manually. Okay, so if I want the probability that at most 3 are spam. Okay, so let's talk about that. So at most 3. So that means 3 is the most. It could be 3 or 2 or 1 or 0. So I could either do binomial PDF. I could do the formula with all those, with these 4 and then add them all together. So it's either I get 3 or 2 or 1 or 0. Or remember, our cumulative function will add up everything up to a certain value. So I can use binomial Cdf. Okay, so if I go to binomial Cdf here, which is right below, so go to CDF here. Okay, so you still have 20 trials, still 13% chance. Okay, but since we're in CDF, it's going to add up everything up to a certain value. So you want to add up everything up to 3. Okay, so I do 3 here, it'll add 0, 1, 2, everything up to 3. Okay, so if I do this in, so we could, let me just write that. So 20.13, and we want to do up to 3. So this will give me, so that should be my work that I'm writing for CDF. Just write out what you type in. So 0.742, okay, 68. So the 8 brings the 6 up. So that'll be 7. So about 74.27% chance. All right, so that one is a binomial problem. Okay, you just have to worry about the arrangements because it's not just the first 5 are spam and then the last 15 are not spam. You have to talk about all the ways that could be arranged. Okay, a camp estimates that the probability a camper forgets to pick up a name tag is 9%. Okay, and as soon as the name tag is forgotten, the counselors call the parents. So you want to know what's the probability that it'll take exactly 10 campers. So that means the 10th camper is the reason they call the parents. Okay, so this one would be, remember, if I want a certain, if I want to know what's the probability a certain number will be the first success, that's the geometric distribution. Which, if you think about it just as a regular probability problem, it's pretty intuitive, because if I want the 10th camper to be the first one to forget a name tag, that means I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want this camper here to be the first one that forgets a name tag, which is a 9% chance, right? So that we want the 10th one, which means these 9 before him, they didn't call the parents, right? Because the 10th one is the first one that they call the parents. So these 9 didn't forget the name tag, right? So if it's a 9% chance they do forget the name tag, that means it's going to be a 91% chance that they do, that they don't forget the name tag, right? So we want the 91, I'm not going to write it, but we want that 9 times, right? So I could do 91, we want 9 of those, and then finally that 10th person is the one that forgets. Okay, so this is my geometric formula. Okay, so I type that in. So we want 9 campers, don't forget. And then finally, the 10th one is that one that does forget. Okay, so that, I don't know why I typed in squares. All right, so we want 9 of these. Lots of 9s happening here. Okay, so that'll give me 9 of those, and then the 10th one forgets a 0.0385. It's about 3.85% chance. Okay, let's continue on. Okay, softball team selects their jersey numbers randomly, 20 jerseys in a box, 13 of which even, 7 of which are odd. Okay, so notice with this one, if they're selecting jersey numbers, if I select a jersey and I get number, I don't know, number 12, well, I'm not going to put the jersey back because someone else can't be number 12, right? So here, there's no replacement. Okay, so automatically we can't use binomial or multinomial, because remember, binomial and multinomials, like these two, they use exponents. So I can't repeat the same one 5 times if we're taking one out each time, right? So the probability is changing. So we can't use those. So this one, for our no replacement, that's our hyper geometric distribution. Okay, so this is when it's done without replacement. Okay, so basically when we have 2 populations, so in this case, we have even numbers and odd number jerseys. So we can split those up and then always divide by the total, because that's what probability is. It's what we want over the total. So this is our formula for our only one when we don't have replacement that we know. Okay, so here we're going to do the hyper geometric. Okay. Okay, so let's split this up. So we have even and odd. So let's look at the even and we'll look at the odd. Okay, so let's see how many tells. So it tells me 13 are even, and we want the probability that we select 9 that are even. Okay, so that would be 13 C9. Okay, so 13 total, we want 9 of them. And for odd, we have 7 are odd, and we want the probability that we select 5. Right, so 7 C5. Just color code this. So that's odd. And then we always put the total at the bottom, right? So the total. So it tells me there are 20 jerseys total, but I could always add the 13 and the 7, so that'll give me 20. And we're selecting, it does tell me, no, it doesn't tell me we select, but because we have 9, we want 9 here and 5 here, so that means we're selecting 14, right? So 9 and 5. Sometimes it'll tell me the total number of players, but we're selecting 9 and 5, so that's 14. So 20C14 at the bottom. Okay, so that's going to be my formula. So let me name this up a little bit. And we always multiply, right? Fundamental counting rule says to multiply. Okay, let's go type this in. So let me get my fraction here. Okay, so type in the 13, and good combination is once again on the probability tab. The third one, so 13C9 times 7C5. At the bottom, we have 20C14. Okay, make sure those add up. Those add up, so it sounds good. So this will be 1001 over 2584. And it's fine if you just leave that. Usually average geometric, you can just leave as a fraction. That's fine. If you want the decimal, we could say 3870, the 8 brings it up to 4. It's about 38, so 39% chance about. But preferably fraction is fine. Okay. Golfer estimates the probability he will land the ball on the green off the tee for par 3 is about 33%. If he tees off on 8 consecutive courses, what is the probability he will land on the green at least 6 times? Okay, so if he's doing 8 in a row, so at least 6 would mean 6 or 7 or 8. So at least 6 means 6 or more. So you can obviously do the probability of each of these 3 and add them up, or we can use our cumulative distribution. Because if we look at the possibilities, he either lands on the green or he doesn't. So it's 2 possibilities, and they're independent, right? Each time it's 33%. So we can use binomial here, right? Because each time it's going to be 33 times 33 times 30. So we can use those exponents. So here we're going to use binomial, right? 2 possibilities, and they're independent events. So no, there's replacement here, basically. Okay, so at least 6. So if I look at my distribution, so he could land, if he's doing 8 courses, right? He could land on 0 times, 1 time, 2 times, 3, 4, 5, 6, 7. So those are all my possibilities of him, how many times he lands on the green. Okay, so at least 6 means we're looking for this. So you're perfectly fine to do, if I were to do, I'll show you that as well. You can do each of these individually and add them up. But if I want to use cumulative, remember, cumulative does a certain value and then everything before it. So everything up to a certain value. So I know everything adds up to 100%. So I could also do cumulative up to 5. So I could do the cumulative up to 5 and then everything. So if I have 100% and I take away that cumulative up to 5, then we'll be left with just the blue there, right? So 6 or more. So I could do 1 minus the cumulative function up to 5. Okay, so let's see, it's a 30. So we have 8 consecutive courses. It's a 33% chance, and we want to go up to 5. So that's what we're going to type in. Okay, so let me go to my distributions here. So binomial Cdf. Okay, so 8 courses, we want 80, 33% chance, sorry, 33, and everything up to 5. Okay, so pretty high, so everything up to 5, so I have to do 1 minus that. So I want to do 1 minus this binomial Cdf. Okay, so we do 1 minus that, we're going to get 0.0186. And then 5 brings it up, so 187. So that'll be my answer. Okay, if you want to do PDF, you just copy and paste it, do 6, then 7, then 8, then add them all together. That'll get you the same answer as well. Okay, let's do the last one here. I'm going to go, since we've done it already, a little bit quicker. I don't want to make this too long. Okay, so if I look at my possibilities here, so we have some are in favor of a delayed opening. We have some in favor of regular in-person learning, and then some in favor of closing the school. Okay, so notice we have 3 possibilities, and it doesn't change each time. So it's 60% into each parent is going to be a 60% chance for delayed, 25%. So anything more than 2, we have to use multinomial. Okay, so since we have 3 possibilities. Okay, so it says, if I look at what I'm looking for, it says if 14 parents are selected at random, okay, so that's 14 factorial. What's the probability that 8 will say to delay? Okay, so we want 8 delaying, 4 will have school, and then 2 will say to close. Okay, because not only 14 arrangements, those 8 are the same. So delay, delay, delay. So if I switches around, it's the same thing. Okay, so multinomial, I look at each one. So it's a 60% chance for the delayed opening. So we want 60%. Remember, we want 8 of those for delay. Okay, in green, we have 25% chance for in-person learning. And we want 4 to have school in person. And then finally, we have 15% in favor of closing. And we want 2 of them to say they close. We want 2 of those. All right, so this is going to be my formula. Because remember, the 8, 4, and 2 are going to repeat. And so the denominator always has to match the exponents. So when you're typing these in. Okay, so 14, and I can't do it like, that's not like a 2 like the last one. So I'm going to use the factorial a bunch of times here. So 14, 8. Once you get the shortcut, it's really just math, left, and then 4. And then 2. I don't really need the factorial for the 2. I'll put it anyway, just so it looks nice. So it looks exactly the same. Okay, so we want 60% chance. 8 of those. 25% chance. 4 of those. And 15% chance, we want 2 of those. So 842, let me check it. Yep, sounds good. Okay, so 0.066. The 49, so the 9 brings it up, so 0.665. So about 6.65% chance of that happening. Okay, let's move on to this last piece here, so the normal distribution. Okay, so tells me that the average time to respond to an emergency call is 25 minutes. We have the variable being normally distributed, so we're using our normal distribution. And it tells me the standard deviation as well. Okay, so what is the probability that emergency response time will be less than 20 minutes? Okay, so since I have a normal distribution, let me sketch this out. So always sketch it. So the average here is 25 minutes. That goes in the middle. Okay, so if I want less than 20 minutes, 20 is going to go on the left, right? So less than 25, so 20 is over here. And we want less than that, so I want this region here. Okay, so you can obviously find the z-score for the 20 and then look up the area in the table. Remember, it's a tail, right? So you're gonna have to do the 0.5 minus this area. But since we're talking about just everyone, we can use normal CDF here. So that's perfectly fine as well. So if I do normal CDF, we can look at our boundaries here. So I want less than 20. So 20 is going to be my upper boundary. And I want everything less than that. So basically down to negative infinity. Remember, for a calculator, we use 10 to the 99th. So my lower, I'm going to put 10, negative 10 to the 99th. So basically negative infinity or everything up to 20. Okay, so the mean is 25. Standard deviation is 4.5. Okay, so this is going to be points. Let me write this out first. Up to 20. And then standard 4.5. Okay, so if I type in what I typed in, if I write what I typed in, we get 0.1332. The 6 brings up the 2, so 3. So that'll be my answer for that one. Okay, for part B, it says now, suppose a sample of 50 calls. Okay, so now we're not looking at everyone, we're looking at a sample. So then now we're going to have to use our central limit theorem. Remember, which says the mean is the same, right? Because when we're looking at samples or a whole bunch of samples, we're looking at the sample mean, so the average from each of these samples. So if I look at a whole bunch of samples, some might be a little lower, some might be a little higher, but they should average out to the mean. So the mean is the same, but the standard deviation is going to be smaller, right? Because if I look at everyone, we're going to have a widespread. It's going to be a lot of deviation from the mean. But if I look at a sample, it's not going to be as much spread, right? So standard deviation, we divide by radical n. So it's a smaller standard deviation when we're looking at samples. Okay, so since we're dealing with a sample here, we can't use normal CDF. We have to, well, you can use normal CDF, but when you're typing in the standard deviation, you're going to have to do sigma over radical n. So if you type in that instead, you can use normal CDF, but we're going to do it by hand just to practice with that. So it's basically the same sketch with 25 in the middle, but now we're looking for the response time is more than 26 minutes. So 26 is slightly over here, and more I want to the right. So I want more than 26. So once again, it's going to be a tail. looking ahead. Okay, so we have to, if I standardize this, so I make this 0 in the middle and write everything in terms of z-score. So value minus mean. And then for standard deviation, we do sigma, which is the 4.5. But we have to divide that by radical sample size is 50. So that's how I'm going to find the z-score. Okay, so if I type this in, okay, so 26 minus 25. You can just type in 1. It's one away. But since we're dealing with the sample, we have to use our smaller standard deviation. So make sure to divide sigma over radical length. So you need that division. So notice a lot tend to forget that in the denominator. So 1.57. Okay, so we can look up that area in the table. So let me pull up my table here. Okay, so 1.50 cents. So 1.5 is here. And if I go over to 7, that's this column here. That'll give me 4418. It looks like 1 point. Double check it. So 4418. Okay, so that means that so this value here is between 0 and then this z-score here. So this value is 0.4418. 4418. Okay, so remember from my sketch, we have to do 0.5 minus that because this entire side is 0.5. So if I take away this 0.418, then we'll be left with that red shaded area. So I do the 0.5 minus the 0.4418. And that'll be my answer. So 0.5 minus 0.4418. Okay, so that'll give me an answer 0.0582. So that should be my answer for that one. Okay, let's look at the last one here, the last word problem rather. Then we just have the short sum at the end. Okay, so it tells me that the average, okay, so the average weight of newborns is 7.5 pounds. Okay, for looking ahead, it does tell me normal distribution. So I'm going to start sketching this right off the bat here. So normal distribution, so the average weight is 7.5 pounds. Okay, so we have 7.5 in the middle, and the standard deviation is 1.25 pounds. Okay, so I know what percentage of newborns will be between 5 and 10. Okay, so I want what percentage, then 10 is over here, right? And then 5 is less than. So what percentage is between 5 and 10, basically? Okay, so if every standard deviation is 1.25 pounds, it looks like this might be work out to whole numbers. So if I do 1.25 pounds, so if I add on 1.25, if I add on 1.25, we're at 8.75. Okay, then if I add on another 1.25, then we're at 10. So notice we're going 2 standard deviations to the right. So we have 2 standard deviations to the right. Right, because that's 2.5 away, right? Which is 2 times 2. So this is 2. So this is 2.5 away, and that's also 2.5 in this direction, right? So it's also going to be 2 standard deviations to the left. Okay, so basically it's asking within 2 standard deviations. So within 2, if you remember, our values will be about 95%. Remember, within 1 is 68%, within 2 is going to be 95% as my answer. Or if you do normal CDF, that's perfectly fine as well, between 5 and 10. It'll give you like 95.4 is the exact rounding. So you could do normal CDF, but you should remember within 1 is 68%, within 2 is 95. That's what this is asking. And then within 3 is 99.7. So those are our 3 values for our empirical rule. Okay, let's finish this off. This last one. Okay, so remember to sum up, we have to plug in. So this is our starting value and then everything up to 4. So substitute all those in, and then sigma is to add them all together. Okay, so if I put in 0, and I want to put in 1, and then I want to put in 2, and then 3, and then 4. Okay, so if I do this by hand, we'll check it on the calculator as well. So 3 times 0 is 0. So this is just going to be 15. This is 3. 3 times 1. So 3 plus 15 is 18. This is 6 plus 15 is 21. 3 times 2 is 6 plus 20. And you can see each time you're just adding 3 more because really just another 3, right? So if I add on 3 more to that, 24, add on 3, 27. And you can obviously do it by hand as well, but you're just multiplying by 1 additional 3 each time, right? So if I do this by hand, I'll get 15 plus 18 plus 21 plus 24 plus 27. So this will give me an answer of 105. Let me just show the plus here. So I want to add these all together. So this will give me 105 as the answer. Okay, and just to review how you do this in the calculator, you can click on its alpha window. So sigma is right here. It's the second one, or let me clear everything. You could also, I believe it's in the math menu as well. Yeah, so we click on math and just scroll all the way down. You should see right here. So go all the way down to the bottom. You have summation. Okay, so obviously you can't use k in the calculator, so you use x. So start with x equals 0 up to 4. And then just type in x instead. So 3x instead of k. So that'll give you the same 105. So you can do it in the calculator as well. All right, so that concludes it. So those should be your answers there. Hopefully you were able to get most of them, or hopefully the explanations helped. So you can check your answers with a different pen, or hopefully you corrected them as well. But that will be all. I'll see everyone soon.